Hello students, welcome to the distance learning class. I am your science subject teacher Kusumgiri, and today I am with the chapter Simple Machine from grade 9. Let's start the chapter. Simple machine. By the word itself, it should be very much simple in structure, simple to use, very simple to handle, very simple in every aspect. So first, what is this, or where do we get to see all these machines? If we go to our kitchen, we can see plenty of simple machines inside our kitchen. If we just look around our house, inside, outside our house, we can get to see plenty of such simple machines. Now, what kind of simple machines we get to see, or you get to see in your kitchen, in your house, outside your house? What kind of such devices you get to see in your daily life, in your daily practice? For example, scissors, very commonly used device, scissors. You might have played seesaw, very common to us. Needle, a needle, we often use it. Knife, a knife, we use it every time in our kitchen. Spoon, see, we use it all the time during our meal, spoon. So these are few examples of many such devices. Now, why do we call these as simple machine? They are very simple in structure, they are very easy to use, and they are very safe to use. They make our work easier, safer, they speed up our work. For example, just look at this device, knife. So what would happen to us, or what kind of difficulty would have to face without knife if we had to cut, for example, potato in our kitchen without knife? Now, but with the help of knife, how easily we chop the potatoes or chop our vegetables. See, means we can do it in short period of time, means it speeds up our work. So let's go to the benefits of simple machine. So while discussing the benefits of simple machines or advantages of simple machines, we easily understand what simple machine is, or we easily understand the meaning of simple machine. Simple machine, they speed up our work, our daily work, let's say. They speed up our work. Simple machines speed up our work. So I just gave an example. They help to do our work in short period of time. Without using simple machine, it would take quite longer time, but with the use of simple machine, we can do the same work in short period of time. For example, there's a huge boulder on the ground. Now we have to suppose we have to turn it. We have to turn it. Now with our bare hand, definitely it would be very much difficult for us. We'd have to, or we may require to use huge amount of force on it, and using huge amount of force also, definitely it will definitely take longer time also to turn it. But using a crowbar, an example of lever, we simply use small amount of force here, and it easily gets turned. Means what? In short period of time, we can do it. Simple machine, they speed up our work. Next, they make our work, they make our work safer. Definitely, definitely, to turn this stone with our bare hands, it may not remain safer. But using this device, this simple device, see, it is very simple in structure. That's why also we call it simple. Using this very simple device, we can turn it very safely. See, so we can say they make our work safer. Let me clean this. Next, they change the direction of applied effort. Now, what does it mean? Simple machines help to change the direction of applied effort. Now, what does it mean? So, I want to repeat the same example. So, to turn this stone, definitely we would have to use force in this direction if we are applying force with our bare hands. But using this crowbar, this is crowbar, we apply force in this direction. See the direction of the force applied here. So, it's downward here, but its effect is in upward direction. With our bare hand, we would have to use force in this direction. But here we are applying force in this direction, just opposite direction. Force is being applied in this direction, but its output is in this direction, upward direction. Means what? This device is changing the direction of our applied effort. So, meaning is clear. I guess the meaning is clear here. They change the direction of applied effort. Similarly, they multiply the applied effort. They multiply the applied effort. Same example. To turn this stone to other side with our bare hand, we need to apply huge effort, definitely, and sometimes even using our optimum effort, we may not be able to turn this stone or turn this boulder to the next side. But using this simple device, crowbar, we apply a small amount of effort here, but this gets turned. Means what? It means, so for example, to get this stone turned to the other side, suppose it requires 5,000 Newton force, suppose. But with our bare hands, we are unable to exert or produce that much amount of effort. So, we cannot turn it. But using this device, this crowbar, this lever, we can turn it. Means what? Our optimum capacity is the same, but using this device, it gets turned. Means it increases, it multiplies the effort that we apply here. So, its meaning is this one. So, we can say simple machines, they multiply the applied effort. And next is they transfer the effort from one point to another point. They transfer. Our output, we are applying our output from this point, but we are giving our input to this point. So, they help, the simple machines, they help to transfer the effort from one point to another point. So, these are the advantages of simple machines. Now, I guess the meaning of the simple machine is clear here. So, simple machines are very simple devices, ordinary devices, which are very simple in their structure, which make our daily work easier, faster, and safer. So, what are simple machines? Simple machines are the ordinary devices or very simple devices which are used to make our daily work easier, faster, and safer. Now, before jumping to Next, on the topics of the chapter, we need to understand some parameters that we always encounter while discussing the simple machine. So some parameters here, load and effort, load, distance, and effort, distance, input work, and output work, mechanical advantage, velocity ratio, and finally efficiency. So these are the parameters which we encounter while discussing this chapter. Now, what are load and effort? What are load distance and effort distance? Similarly, input work, output work, mechanical advantage, velocity ratio, and efficiency. Let's discuss one by one. First, load and effort. This is a crowbar or a lever. After this, we'll discuss the types of simple machines. This is one of the simple machines lever. So this resistance which we need to overcome is termed as load, in short capital L. In short, we symbolize this load with the letter capital L. And to overcome this resistance, the force that we apply, we term that as effort, in short capital E. So load, the resistance that we overcome using the device is load, and to overcome that resistance we apply some force and we term that as effort. So load and effort. Now suppose we need to lift it up, for example, or in another device was pulley. This is a pulley, and the load is here. So to pull it up to some distance, to some height, definitely we need to pull it down. We need to pull it down. So we apply our effort here, and this is the load. Now, while pulling this downward, definitely it moves upward. Suppose it is now here. So this distance, this much distance, it is the distance traveled by load. So LD here means load, distance, and this is the distance traveled by effort. So this is effort distance. So while doing the work, definitely here effort travels or covers some distance, or the point of effort applied that travels. So that is the effort distance, and definitely with that load also moves or covers some distance, and the distance covered by load, that is load distance. Same happens here also. If you apply some effort here, this point travels up to here. So this is the distance traveled by effort, so it is effort distance, and this is the distance traveled by load, so it is load distance. So I guess you are clear on these 2 points, load distance and effort distance. Now, input work and output work. Input work and output work. See, work means what? Work means force into distance. Force into distance. So this is the distance traveled by effort. Similarly, this is the distance traveled by load. Now, input work input is effort into or times effort distance. Input work means work done by effort. Input work output. The result that we get, the work that we get, or the work done by the machine. That is load and load distance. Load and load distance is the work done by the machine for us. And this one is the work done by us to the machine. So input work is the work done to the machine. Output work done by the machine. It is to the machine, it is by the machine. So work done by our effort, the effort that we apply to machine. The work done by that effort is input work. And work done by the machine for us is output work. So mathematically, input work is the product of effort and effort distance. Effort and effort distance. Similarly, effort and effort distance, this is input work, and output work done by the machine, which we expect from the machine to get done for us, that is output work. And that output work is the product of load and load distance. Load and load distance. Load and load distance. So these are the meanings of input work and output work. Next parameter, mechanical advantage. Mechanical advantage, what is it? Mechanical advantage, in short, we may write with these capital letters M and A, MA, mechanical advantage. Now, what is it? This is mechanical advantage. What is it? It is the ratio of load to effort. Mechanical advantage is the ratio of load to effort. So both have the same unit Newton. So it doesn't have any unit. Mechanical advantage, it doesn't have any unit. So ratio of load to effort in a machine is mechanical advantage. What is mechanical advantage? Ratio of load to effort. Ratio of load to effort is mechanical advantage. The next is velocity ratio. Velocity ratio, in short VR. Now what it is? Velocity ratio is ratio of effort distance to load distance. We are saying velocity ratio of velocities, but writing effort distance to load distance. How come? Velocity ratio should be the ratio of two velocities, but here we see ratios of two distances, effort distance and load distance. So let me make it clear how velocity ratio equals to effort distance to load distance. Let me make it clear. Velocity ratio. Actually, velocity ratio is the ratio of velocity of effort to velocity of load. Now let me draw a figure here. I'll draw a figure of lever again. A load is here. We apply some effort here. Now, with the application of some effort here in downward direction, definitely it moves this way. So load finally reaches to this position, and effort travels this much distance, this effort distance, and this is load distance. Load travels this much distance. Now, the time taken, now velocity of effort means velocity of effort. What is velocity? Distance traveled per time. So, effort distance by time taken. What is velocity of load? Load distance travel in certain time. Load distance. Now, the point we need to understand, the time taken for this effort to travel from this point to this point, and time taken by load to travel from this point to this point. Are these equal or not? Definitely, they are equal. So, when we push it from here, see, it moves this way. So, time taken by this point to travel up to this point, and travel taken by this point to travel up to this point. These two are always equal. So, these two times, they are the same. They are the same. So, finally, we get effort distance by load distance. So, see, final velocity ratio is finally equal to the ratio of two distances, effort distance and load distance in this device. So, these are the ratios of the same physical quantity. So, again, it does not have any unit. So, I guess you are clear on it. So, velocity ratio is the ratio of effort distance to load distance. So, dear students, we will continue this chapter in our next class. So, this was for today. Have a nice time. Thank you. Bye-bye.